As a concrete example, say you're given this circuit and you're asked to find both the Norton and the Thevenin equivalent of it, as seen between these two circles, top and bottom. So our first step using the first method, which is simplification, is to see if there's any resistors that we can combine or see if there's any source transforms we can do. So there are no resistors we can combine. These two resistors are not in series or parallel, but we can do a source transform. Specifically, we can do a source transform to the left of those two circles. And if we do that source transform, we'll see that we get these 4 ohm and the 12 ohm resistors in parallel. So that would give us a 20 over 4 equals 5 amp current source. Our 4 now is in parallel with our 12. And we've got a 2 amp source that's also in parallel. Well, this is great because everything's in parallel, so now we can really begin combining things. There's nothing special about the order of our components. We could have just as well drawn our 5 amp source next to our 2 amp source. And similarly, we could have just as well drawn our 4 ohm next to our 12 ohm. So armed with this, it's pretty clear that the 2 and the 5 are in the same direction, so that gives us a 7 amp equivalent source. And that 4 and that 12 are in parallel. And again, if that's not obvious, you can redraw this section. You've got your current sources over here. And we could redraw our 2 resistors like that, just splitting the line off a little bit. And now it's clear that these resistors are joined top and bottom, and that we could draw a isolating ring around the outside with only 2 wires coming out of it. And that's what lets us say that these are in parallel. So we've got this 4 and this 12 ohm in parallel. Instead of saying the equivalent resistance is 1 over 4 plus 1 over 12, we're doing product over sums. Because these are multiples of each other, you can simplify it in another way. You can say you can create the smaller value by just a bunch of 12s. How many 12s would you need in order to create a 4 ohm resistor? Well, 3 12s will do it. These 3 12s, all in parallel, are the same as a 4 ohm resistor. So now let's put our remaining 12 in, and now you can see there's 4 12s, so that has to be a 3 ohm equivalent. And if you didn't see that, you could just as well say 4 times 12 over 4 plus 12, or you could say, you just have to know how to divide by 16, or you could do the more complicated 1 over 4 plus 1 over 12, and for that you definitely need to use your calculator. I'm just giving you a way that you can figure it out in your head. So now we've got a single current source in parallel with a single resistance. So this is, by definition, our Norton. Now to find the Thevenin equivalent, we could use a source transform. Multiply I times R to get V. 21 times 3 is equal to 7 times 3 is equal to 21 volts. And our 3 ohm becomes in series. And then this is our Thevenin equivalent. And that's how to find a Norton or a Thevenin equivalent using method 1, simplification, which will generally work as long as your circuit is relatively simple and you've got no dependent sources.